You guys ready? We can do this? We're going to finish up pointers, right? And remember, pointers are created with just using the star, right? At creation, creates a pointer to, right, whatever type that you say. So an int star pointer is going to point to a what? An integer, right? Give it any identifier we want, and then we can also allocate dynamic memory with that by saying new, right? New int allocates a new integer, right? Becomes a memory address. Memory address gets stored into a pointer, right? So we saw that, which makes P as a pointer, and the new int makes this guy, which is unnamed. And so the only way to get to it is star P. I'm gonna go with that basic concept, right? For arrays, same thing. Int star A equals new int. The only difference is here we put square brackets on it and give it some size. All right, so syntactically it's the same, just whether or not you have the square brackets and how big you want that dynamic array to be. Which, once again, int star A creates me a pointer called A of type int star, right? New int 5 creates me a new integer array of size 5, right? Returns the memory address of where it's located, so in essence, the first, right, element of the array. For us though, right, we don't say star A, right? We say A bracket 0, right? And A bracket 1, right? Because remember, once you create a dynamic array, you treat it like it's a what? Like it's an array, right? And so you do everything with the array that we've done already this semester. I think we could have done that, and last class would have been a lot shorter, right? That's all you need to know. Questions on any of that? So today we're going to dive deeper into what's happening when this happens. So where is this memory coming from? Where is this memory coming from? We'll talk about how to get rid of it. So we create it with new, and we're going to have to get rid of it with delete. So we'll talk about that. And then we'll get into dynamic objects and destructors, which destructor just sounds so cool. Right? I think it sounds like a transformer or something. Our destructor function. We're going to talk about that. Well, look at all this fun stuff we get to do. Isn't that exciting? Aren't you guys excited? You guys came back, so you're either glutton for punishment or I'm not sure what. So, well, welcome back. So let's talk about a dynamic multi-dimensional array. When I say multi-dimensional array, what do I mean? What do you got?
2 arrays.
2 arrays, right? Or 3 or 4, right? But a dynamic or a multi-dimensional is an array that has more than one indice. So they can be 2-dimensional, which you can kind of think of as like rows or columns, right? It has 2 dimensions, right? You have 3-dimensional arrays, so then they're like X, Y, rows and columns, but then also Z, right? They have this like 3-dimensional aspect to it. And then 4D, 5D, I don't know how to do any of that visually, but you could if you wanted to, right? But Fabian brings up a good point, right? He said 2 arrays. So kind of, we're going to find out it's actually more than 2 arrays, but it's this concept that we have arrays of arrays, and that's how we get this going. So a multidimensional is an array of arrays, and if you get more dimensions, then it's an array of arrays of arrays. You get more dimensions, right? We can keep doing this forever, right? And so what we need to create is this concept of an outside array, right, which gives you how many rows you want, right? It gives you your first dimension. And then we need that outside array to point to basically inside arrays, and that gives you your rows. And so you end up with places to store data, right, in these rows, or sorry, these columns, right, and they each have their own indices, okay? So let's try to see if we can figure it out as a class what the types are. So if I want to store integers, then the types of these arrays have to be on a base type of what? Int, right? Try to start out easy, right? So these arrays have base types of int, because that's where I want to store the data. Everyone good so far? All right. Which means that this array, right? Everyone good? This is an array, right? Needs what base type? Int star, right? Because int star, an integer pointer, is the only thing that can point to integers, right? So if we go the other way on the arrow, we add stars. So here, right, this array is of int star, right? This is indices 1, 0, 1, and 2 as well. Make sense so far? But we know arrays, to get to them, what do we need? Okay, beyond just the index. So 0, 1, and 2, I can't just say 0, 1, and 2 in my code. What do I need?
Another set of brackets.
A pointer, right? So I need another variable, right? So I need something out here, right? And we know that that thing points to the first thing in the array. And we go with that concept, right? We can call it MA for multidimensional array. Good so far? What's its type?
And 2 stars?
Right? And 2 stars. Because 2 stars have to point to 1 star, and 1 star points to no stars. Right? So we kind of tippy-toed around this last class because we're like, will we have pointers with 2 stars? Yeah, we will. One of the places we see them is with a 2-dimensional array. You can kind of think of this as some multi-dimensional array that got created with what? Rows of 3 and columns of 4, right? That's kind of what we created on the board, right? Because if I want to put 6 right here, right, I would say 6 gets assigned to my multi-dimensional array, and then I would give my 2 indices. Does that make sense? So the first indice would be what? 2, because it's row 2, which is really row 3, right? And then what? 2 again. Oh, I made it too easy. 2 and 2. Right? Let's talk about this though. Right? MA bracket 2, right? That's just the name of the array, go to this indice in that array. Everyone good with that? So MA bracket 2 says go to this array. The square bracket says follow the arrow, right? And the 2 says go down 2 spots. Everyone good with that concept? So MA bracket 2 is that purple X right there, which is a what? A pointer, right? So if I see outed MA bracket 2, it would work. It wouldn't say, you didn't give me enough indices. It would work, but the value that would be outputted would have been a what? A memory address. Does that make sense a little bit? The first bracket basically takes me from this pointer to this pointer. Does that make sense? This pointer is a pointer to a what? An array. And how do I get two things in an array? What do I use? Square brackets. Does that make sense? Which is why I add another set of square brackets, right? Because MA2, this thing right here, is here. And then I want to say, I want to go to index 2 of this array, right? Ignore everything else that's going on, right? Just this array. How do I get there? Square brackets, right? And then 2. Does that make sense a little bit? All right. Let's see if we can make it syntactically, right? What do I need to create first? The thing on the right or the thing on the left? The thing on the left, right? Because if I create my array, I need to store my array in some other place, right? And if I create this array, I need to store it in some other place, right? So I want to start on the left side. So syntactically, what would I do to create this? Equals something, right? Yeah. Right? Well, base type event. So how do I create something dynamic? What word do I use? New. So it's a new, not a mu, I don't know what that is. A new, right? And the array, right? I want to create this array. So what's its type? And star. And to make an array, what do I use? Good. Brian says square brackets. and then whatever size I want it to be, and we'll just type it in, right? Which size do I want it to be here?
3, right?
Good. Int star MA creates this. New int star bracket 3 creates this, and the equal sign says store its location back into MA. Does that make sense so far? Right? I created a how many dimension array right now? One. This is a one-dimensional array, right? It's just a regular array. You could treat it like a regular array. The difference though is that this array doesn't store integers, it stores what?
Memory
Pointers, memory addresses, 2 integers. But pointers to integers can be pointed to regular integers, dynamic integers, or they can be pointed to integer arrays. Does that make sense? Right? So they can work with either. So I have a bunch of pointers that I can now point to whatever I want to point to. So I created this, but now I need to get to each of these spots, right, and create these guys. Which means what do I need? Good. Right. Int I starts at what? 0. I less than size, which is? Please, please, please do not say less than or equal to 3. Okay. We still make that mistake. I know it happens. I used to make that mistake, but please don't. It's too many. Right? 0, 1, 2 is 3 things. Right? 0, 1, 2, 3 is how many things? 4. But my array's only of size what? 3. So don't put the equal sign on there. This is the thing, like as a teacher, that I've just been saying like year after year to all my students for forever. And I'll keep saying it, and that's okay. But don't do it. I know, right? I just get angrier each year that I said this before, even though you're new students, right? I told you before. No, you haven't. Those were other people. Those were people dumber than us, right? That's what you're supposed to say.
I think in 10 years we'll really start to better you.
Yeah, I think so. I think that's probably true. Oh yeah, yeah. In 10 years, I probably won't even say anything. I'll just like, screw it. You want to put the equal sign there? Go for it. You want to cry at 11 o'clock at night while you're doing your lab? Then that's fine. I'll be sleeping soundly in my bed. Okay, so this loop gets me to each element in my array, right? And it really doesn't, right? That loop just counts. 0, 1, 2. Agreed? But I can use the index with my array, right? I can say what? MA bracket. Good. Which first iteration is MA bracket 0. Second iteration is MA bracket 1. Third iteration is MA bracket 2. Everyone hear that? If I'm here, how do I create this?
A new int, right?
A new what?
A new int.
Right, gets assigned a new integer array, right? And then basically I'm saying how many columns do I want, right? And so in this case I want 4 columns, so what do I put in the square brackets?
4.
4. I want us to realize that this line of code and this line of code are doing the same thing conceptually. They are taking a pointer and pointing it to a new array. This takes a pointer and points it to a what? New array. Everyone sees structure is the same. New type square bracket size. New type square bracket size. It's the same. Even though one says int star and one says int, structurally they're the same. New type square bracket size. Okay? So the logic doesn't go out the window because we have 2 stars or 3 stars or 8 stars, right? Right? We just point it to, we're not going to go to 8 stars. That seems a little crazy. I need to end I put a curly brace with my for loop, so I need to close the curly brace. That code creates that. Does that make sense? Right? Do you believe me?
Yes.
You do? Do you want me to draw it? Okay. We can do it like this. First line of code creates this, right, over there. The next line of code loops and individually creates these. So why are multidimensional arrays arrays of arrays? Because they're arrays of what? Arrays. So where you store data in a two-dimensional array is not in one big table array, right? You actually store it in as many rows arrays that you have. Right? We just conceptually we like to just take these three and do what to them? Squish them together, right? And then we can say we have rows and columns. Which makes it a lot easier conceptually for us to understand what's going on. And you're getting tired of me saying this, but once you create a multidimensional array, dynamic multidimensional array, you treat it like a what? An array, right? So it's a multidimensional array. So if we want to get to anywhere, we use how many sets of square brackets? 2 for a two-dimensional, right? If you wanted to get all 3D, then this array would have multiple indices, right? That would also point out to their own things.
We're going to talk about heap versus stack memory.
Mm-hmm. Like soon. Like maybe in 10 minutes. Stay awake. We're going to get there. This doesn't really apply to what we're saying now, but it is perfectly valid for you to make what are called jagged arrays. All right. Why do you think we call them jagged arrays?
Different sizes.
Right, they're different. They're different sizes, right? Which is fine. You could do that. There's nothing wrong with that. But you can't now uniformly loop through everything because they're jagged. Right? The two-dimensional array is really nice because we know how many rows and how many columns, and it's all the same. But sometimes you'll store data like this, right? Although these would be like object pointers that point to objects. Hey, that's what we got to do in our next assignment. I'm excited.
Oh.
All right, I got to skip some slides too. All right. Hey, look. All of it in better handwriting. Right? You'll notice in the slides I say rows and columns, right? Because the whole point of it being dynamic is that I don't have to know the size until when? Creation, right? While the program is running, right? If I knew it was 3 by 4, I could just create a regular dynamic array, right? But here, right, we're adding the benefit of creating it when the program's running. Look, all these slides we're going to skip, because we already did all that. Right, who needs slides? I don't. We don't even need to look at the thing. We're good. You guys good? You're like, I don't even like dynamic or two-dimensional arrays, so let's just not talk about them. Right? We're not going to do anything this semester that's going to make you use them, so I guess that's good for you. All right. What are objects? I'm trying to make this a philosophy class.
They're like blueprints,
What is
right?
the meaning of object? No, what's an object? So you said blueprint, but really, it's something created from the blueprint, right?
Yeah.
Right? The blueprint is the class, and the object is the thing created from the class, right? So it's just a what? Well, data type's the class name, so the blueprint's the data type. It's just a variable, right? An object is just a variable. It just happens to be created from a blueprint, a class, right? So we call them objects. Right? Obviously, they have like behaviors and attributes and all this other crap associated with them. But for us, they're just an object. I mean, they're just a variable, right? That we can use the dot operator on. Right? You can't say int x, x dot something. You can say car x, x dot drive. Does that make sense a little bit? Right? So if I do int star x equals new int, right? It should make sense that I can do car star x equals new what?
Oh.
Are we good with that? I'm not trying to make anything profound here, right? Remember earlier I said type, right? Type star name equals new type. Right? As long as the two types match, you can do whatever you want, right? When we create classes, right, we're creating user-defined types, right? So everything that we talked about last class about how to create dynamic variables apply to dynamic objects, because objects and variables are the same thing when you talk about how you create them. Does that make sense? Can we go with that? So Here I have a structure called record. Remember, structures and classes are basically the same thing, right? We treat structures as having only data. We treat classes as having data and functions, but basically they're the exact same. So when I say struct record, I'm creating a new data type, right? And that new data type is called record, right? So if I wanted to create a dynamic record, what would I have to say?
Record star my record or something?
Right, record star. Don't you love we're so possessive in code, right? My record, right? Not your record, not anyone else's record. Some people get really mad when you name your variables with my whatever. But in this case, it's my record, so right equals new record. Yeah. I said create a dynamic, so if I wanted to get technical, right? When I said create a dynamic object, everyone good that this is technically what creates the dynamic object, right? Saying new record, saying new creates something dynamic. But if I don't store it anywhere, then it doesn't matter if we created it, we don't have access to it, right? So new record creates the dynamic object. The assignment operator in the record star my record says, hey, put it here, right? As in, point this pointer to that new thing. And if you can't read my handwriting, right, that's what the slides are. I also said my record in the slides. You probably got the bad habit from me. Creating from a class is the same, right? If I have a class record, right, it's the same, right? It doesn't matter if it's a class, a structure, a regular integer, you create the same, right? Type star identifier, right, name of your variable, gets assigned a new type. And the key is you don't mix the type. You don't say int star p equals new double, right? The types have to match, right? Any type, which classes and structures are types, right, work fine. Okay. What happens when an object is created? You call the constructor, right? So technically, when you say new record, it has to call a constructor to create a new record, all right? If I don't put any parens on it or any arguments into it, what do we call that constructor? You remember?
Default.
The default constructor. So this right now is called the default constructor. If it had, right, more than one constructor, or maybe not a default constructor, but constructors that take, right, arguments, right, values in, then we put parens and then pass in whatever I want, right? So it looks a little bit different than when we create it, right, not dynamically, but we should know that, right? So you could do something like this, right? Record star my record equals new record, and then notice I add the parens, right? Not square brackets was for an array, parens, and then pass in some values.
So the new record without parentheses is not the same as new record with just empty parens?
Well, if you put empty parens, it'll still work, but they're not needed. It's something I really hate about C++, where if you call the default constructor, you don't put parens. You kind of make it look like a variable, basically. But as soon as you start calling non-default constructors, then you add parens. So it's not consistent, and I don't like that.
So if you do close parens, it won't call the default constructor.
If you didn't open and close, it still would.
Oh.
But it would just ignore the parens. It's just extra.
I see.
Am I good? So what did this do? It created my record, which we all have decided is mine, right? Of type record what?
Star.
Record star. So it created that. Then it created a new record, right? Which has a number and a grade. Everyone go with that? It has 2 data points in this object, right? This whole thing is a record, right? And this my record points to it in memory, right? Where it exists. Everyone good with that concept? What it created? Okay. So then the question is, if I want to put 10 right there, how would I do that? Okay, so normally to get 2 values in an object, right, we use the dot operator. Good. So what? My record dot num equals 10. Everyone good with that? What is that? Is that an object? It's a pointer to an object. Right? Everyone's starting to get why pointers are annoying and hard. Right? My record is not an object, right? We use the dot operator on what? Objects, right? We use the dot operator on objects, not on memory addresses. Agreed? Remember when I did this and I said, star my record? Remember? Right? Because to get to what a pointer is pointing to, we use the dereferencing operator, the star. Right? So my record is not an object, it's a pointer. Star my record is a what? An object. So how do I need to change my syntax? Put the star where? Agreed? Dereference the pointer to get to the object. Use the dot operator to access a member of the object. Look how far you've come. Right?
It's all downhill from here.
It is. Okay.
If you didn't use the star with,
It would say, it would give you a compiler. I'm not sure what it says, but it talks about like not an object.
It's like you're trying to point.
Because you're trying
a
to,
pointer.
right? You can only use the dot operator on objects, and instead you're doing it on a memory address, and it's like, I don't know. And maybe I'll make that error for us on purpose.
unless you have an object that happens to be called my record.
Yeah, right, right. Okay, now if this wasn't bad enough, right, because that right there is kind of ugly in itself, right? The dot operator has a higher precedence than the star. Isn't that annoying? So the dot operator has a higher precedence than the star. So actually what this code says is do that, right? And actually technically it says do that, and then dereference whatever that is. Which isn't going to work because we just said the dot operator won't work on a memory address. Right? So how do I fix precedence issues? Yeah, slap some parens. Oh man.
Oh,
Oh man.
I see.
Doesn't that look great? Star my record inside of parens, which now says go to here, and then the dot operator says access the num, right? And the assignment says put 10 into it. Isn't that lovely?
That's a little complicated.
And on top of that, we almost always in C++ make our objects dynamic. So we do this all the time. As far as create, actually I should say, we don't do this, but we do this all the time, creating new objects, right, and that kind of stuff. So we have a different operator that C++ created because that's ugly.
What's the main difference between like C and C++?
Classes. Yeah. So you can have structures, so you can have data objects in C, but not classes. That's the big difference. Which then adds in things like strings and IOString, all this stuff in C++, because that's all class-based, not C-based.
So with C, you have to like fill everything yourself.
Yeah, C is pretty manual. Like if we think of C++ as the manual car, and like all other languages as an automatic car, C is, I don't even know what. You have the monkeys in there, like yeah, right? Doing something else, I'm not sure. But, yeah, right? Exactly. Something. Yeah, you have to hitch the horses and get going. Anyone know what operator we have?
Arrow operator.
Yeah, the arrow operator. You're like, I didn't know if I was supposed to say that way long ago. My record, and then it's a dash and a greater than symbol, but it's called the arrow operator because it looks like an arrow. So you do that.
Much easier.
Right? The arrow operator both dereferences, so the star, and accesses the dot all at the same time. So you use the arrow operator on pointers to objects, and it moves down the arrow and accesses at the same time. Okay? If you want to write it like this to spite me all semester, you can. It will compile.
It'll work.
You won't lose any points. Right? Kind of looks cool until it gets even more complicated, right? But right, the arrow operator really is what you should use when you're creating, right, dynamic objects. So while the star is used to dereference stuff, you'll see that the star gets pulled into the square brackets with arrays, so you don't actually use it. and the star gets pulled into the arrow operator with dynamic objects, so you don't really use it either. So it's rare that we actually use the dereferencing operator, because we'll use the arrow operator or we'll use the square brackets. Make sense? Questions there? That's probably what my slides say. Right, blah, blah, blah. We do need to look at an example of this because we're going to do this a lot this semester. Okay, dynamic objects. So here's a scores class. You'll notice that my score class has two private data things, quiz name and score. So I don't have access to them no matter if I make my object dynamic or not, right? The only way I can access it is via my member functions. All right, so let's look at in main how I do it. All right, so I created a class called scores, so I can say score star object equals new scores. Right, everyone see the new scores and the parens because I'm calling what? Constructor, and I'm passing in some values. So I'm calling in a scores constructor that takes a string and an integer, right? So it's going to look for that, which there is one, and it just takes those values and stores them into their thing, right? And then you'll notice that because object is a pointer and new scores is dynamic, right? It's a dynamic object. Notice that everything here is not the dot operator. What is it? It's a pointer, right? So we use the arrow operator, right? So if I want to call my member functions, I have to use the arrow operator. Let's see if this will compile.
Oh.
What? Oh, you know what I probably should do?
Undefined records.
Probably save it. Rookie mistake. You're like, we don't have to do that on coding. It automatically saves. Right? So midterm number 189, right? Because we had, right, a new scores thing with midterm number 189. And then I'm going to set the quiz name score, so I'm going to change it. Right? So it'll be midterm 2.
Midterm.
Man, I can't. All right, and you guys all got 100 on the second midterm. Now it says midterm 2. Right?
A's for everybody.
Yeah, that's right. Why not? You guys are half paying attention. It's good. It says new. All right, let's put a dot operator in there. That's right. Request for member output in object. So object was the name of the variable, right? The member function we're looking for is output, but it says object, which is of pointer type score star. Look at the error message.
Maybe you meant to use this.
Maybe you meant to use the arrow. Wow. This is like the first time where the compiler was actually kind to you, right? Maybe you should have used the arrow operator. Yes, maybe you're right. Okay? You're not even being snarky, right? And it even tells you on line 46, you said object dot output, and maybe you want to use the what?
Arrow operator.
And do I want to use the arrow? Nah, right? Let's just leave it. Let's leave it junky. Right? Yeah. Right? Parentheses star. I don't want to use the arrow operator. I want it to work, but I want to do it weirdly. Power. Didn't work. All right. My screen gets dark when it gets low on power. That's my cue to say I've talked too long. Right? You could do something like this. Right? And that will actually technically work as well. I don't have to use the arrow operator, right? It'll work just fine with that. Questions on dynamic objects? They are just variables, so we create them like we create other dynamic things. But now I need to use the arrow operator on them as opposed to the dot operator because they're dynamic. Dot operator does not work on pointers, right? Dot operator only works on objects. And so since I have a pointer, right, I need to get here, and that's where the arrow operator comes. You ready to get crazier? Okay. Let's talk about dynamic arrays and objects. And let's talk about dynamic objects and arrays. And let's talk about dynamic arrays of dynamic objects. Anyone get scared a little bit? That's what your assignment's on. Dynamic array of dynamic objects. But let's talk about some stuff before that, before we get too much
dynamics in that one sentence.
right? At least it's not like thermodynamics or anything weird like that. So does this make sense? A dynamic array, which is just an array that's created with the new operator at runtime, right? Can it have a base type that is a structure or a class? Can you make an array of objects? The answer is yes. And if you can create an array of objects, you can create a dynamic array of objects. Right? No, it's not really dynamic and dynamic yet. That's where things get crazy. Okay. Inversely, you can have a structure or a class, right, a blueprint that you're creating, that inside of it has a dynamic array. Okay? So it works both ways. You can have a dynamic array of objects, or you could have an object that has a dynamic array inside of it. Okay? Which means that we need to combine all of the syntaxes that we've learned with the dot and the star and the new and the square brackets, and we got to put them together in the right order depending on what it is that we're trying to create. All right, so here's my record structure, right? So record is a new type that I can use, right? If I wanted to create a dynamic array of records, right, let's do it of size 4. I'm going to run out of space on the board. If I wanted to create a dynamic array of 4 records, what would be the syntax?
We start with record.
Okay, good. We know we say record. And if it's dynamic, what do we need?
Star.
1 star, yeah. We're not going to get 2 stars yet. And then we need to give it a name. Can we just call it R? Are you guys okay with that?
Yeah.
We can be lazy. Right? Gets assigned a what?
New record. An array, right?
Yeah, I said array, so what do I need?
Brackets.
And then I said of what size, I don't remember.
4.
Record star R creates R, which is a pointer of size record, or of type record star. I probably should not, because this will help in our conversation. I should probably make it a little bit smaller, right? Remember we said pointers are really small space-wise, right? Look like they took up 2 bytes in my computer with how much memory I have. Usually 1 to 2 to 4 bytes, right? And then this gives me a new record array of size 4, okay? I'm trying to do big on purpose.
Is that 4 separate record objects?
Yes.
In the array.
Right? They're all theoretically the same size, but I'm really bad at drawing. Right? And then each of these has what? Good, right? So each of them has a number and a grade.
Think about like the bracket versus box factor.
Right? There's so much you could do with it.
And making them dynamic, you can change them while the program is running, right?
Yes, you can. Well, they get creative while the program's running.
Yeah.
So I can say how many I want. But the key thing to know is that each of those objects is not dynamic, right? They got created in an array. The array is dynamic, that's why I use new, but these objects are not dynamic, right? I don't have pointers to each object inside of the array. I just have a pointer to the array. Does that make sense a little bit? And in fact, this is how you kind of make a rudimentary database in a program, right? Because it's an array of structures, and the structure can be whatever data you want, right? And now I've created 1, 2, 3, 4 places to store that data, right? So there's a bunch of data that I can now store in my program, pretty easily.
Use it up.
So then the question becomes, right? If student 1 wants an A, how do I give student 1 an A? Make sure you give the right student the right grade. You're student 1, so you want to do it correctly, right? How do I give student 1 an A?
R bracket.
What?
R bracket. something.
R bracket, good, right? Because it's a dynamic array, so we don't use the star, we use, it's just an array, right? So R bracket,
1.
what do I put in there? 1. Get to sign something, right?
99.
But I don't sign it yet. What is R bracket 1? Is that not R bracket 1 right there?
Mm-hmm.
Right? Ooh, good question. Do I need arrow operator grade? Or is it dot operator grade?
I guess just dot.
Why is it dot and not arrow? Because it's, okay, so it was an array, so the dynamic thing was this arrow, and the square brackets got me, right? Remember, I'm now here where this circle is. There's no arrow there, there's no nothing, it is just this object. Right, so to get to this object, I would use the dot operator. Dot grade gets assigned a name. Does that make sense? Remember, once you create a dynamic array, it's just an array. So I use the square brackets to get to the index, or really the element of that spot. And then the element is an object. How do I get to things and objects? I use the dot operator. Obviously, you say arrow because we literally just talked about arrows for a minute. But really, it's the dot operator, right, for this. Right? Does that make sense? Get to the spot in the array, then access the member of that object, which is an element of the array, and do what you want. So that's an array of objects. It happened to be dynamic. It didn't have to be dynamic. It just happens to be that. Right? But I created it dynamically. But once you create a dynamic array, you just use square brackets like regular arrays. Right? Which gets you to each thing here. Right? And then what? Then you use this. Right? You just add an object. Okay? Anyone see a downside to creating an array of objects? A lot of memory, right? So, right? I mean, hopefully it's only taking up as much memory as I need it to. Right? I have 20 students, so I want to create an array of size 20. But it allocates all those things, right, once you start running the program. Basically, once you load the program, right, it's going to create all those big objects, right, all at one time, right, and take up quite a bit of memory. Make sense? All right, we'll come back to that here in a minute. All right, let's do the opposite, which is to create a structure or a class with a dynamic array. I'm doing structures today because structures are public, so I don't have to put the word public in my slides. Remember, structures and classes are basically the same thing.
They don't have a public or private.
They do, but structures by default are public and classes by default are private. So to make classes useful, you have to say public, but you can just create a structure because they're always public. But you can make private. All right. All right. I say create a structure with a dynamic array, although, right, have I created a dynamic array yet? Remember, your check is, did he say new? Did I say new? No. So have I created anything dynamic yet? No. But can pointers point to dynamic things? Yes, that's their whole point, right? They're supposed to point to dynamic things. So I made a spot in my structure, right? And the object that gets created from that structure, I've created this spot to store memory address, right? Which can be a dynamic variable or it can be a dynamic array. So if I say record grades, right, that creates me, I'm going to do it over here. That creates me an object or a dynamic object? An object, because it doesn't say what? It doesn't say new. So it's just a, right, a variable, an object called grades that has a num and has a grade, right? And technically they're both garbage so far. Everyone good with that idea? They're both garbage so far, right? Num is of type int, and grade is of type what? Char star, right? It's a pointer. So it allows me to do this. Grades, which is the name of my object, dot, because it's not dynamic, right? Grades dot grade. So we're talking about this little spot right here. Gets assigned a new char bracket 10, right? New char bracket 10, right, says create me a new character array of size 10, right? And everyone sees the 10, but really it says 4, right? That's what you guys all see. Yeah, why not? It says 4. This board is like tiny, right? And then my new character array of size 10, right, gets stored into grades.grade. In essence, that means grade points to. That makes sense? Now this is kind of interesting. My object has created data that's not really a part of the object. Does that make sense? Right? It has a pointer to data somewhere else, right? But it kind of allocated it, right? And it's not technically part of the object, but currently the object is the only thing that knows about that. Does that make sense a little bit?
So the benefit of that is like you could reuse that record object.
Right.
Different size.
Right. Imagine I created a class that had an array in it, but I didn't know how big I wanted that array to be. And in fact, I think, right, in essence, in this dynamic object, maybe not. What did we create in here? Oh no, we just created one. Never mind. But yeah, if I wanted to create something, right, to hold students' grades, but I wanted to make it a class to make it easy for a user to use, right? You could, on creation of the object, say, I want that array to be of size 5, or 10, or 20, or 30, right? And in your constructor, you can allocate that. So it makes it, right, it makes your object or your class be more useful to people, because you can kind of change the size of it. Oh, and then we go back to the question of, if I want to put 10 right here, how do I get there? Where am I going to start? I got to start at grades. That's the only word that I have, right? So I'd say grades, right? Because the way to get to here is because it's not dynamic, right? So grades.grade is this arrow, agreed? What does that arrow point to?
An array.
An array. So once you have an array, which grades.grade is an array, what do I use?
Brackets.
Right, good, brackets. And then what location is that?
1.
Right, it's technically location 1. Grades.grade is an array. Bracket 1 is the first index of that array. So grades.grade bracket 1 is an element, right? And we're going to put 10 in that. And we're good that the dot has to come first because the array is inside the object. As opposed to my other example, the square brackets came first because the object was what? Inside the array. When the object is inside the array, we use square brackets first to get to the object. When the array is inside the object, we use the dot operator. Who's confused? Okay, a little bit. It's a lot, right? But the key is just use the syntax that you would normally use, right? Break it down. Don't worry about the array. How do I get to a member of an object? I use the what? The dot operator. Okay. That's how I get to that. Now, we said that this theoretically is inefficient, right? Because it's going to allocate a lot of memory all at once. All right, so let's change this example a little bit.
You have dynamic now.
Oh yeah, that sounds great.
Because then you can just
I'm so excited.
create the array, then they
So
create the
let's
object.
talk about this little array, right? And then we could say that this thing points to, right, a num and a grade object, right? And this one points to a num and a grade object. 0, 1, 2, 3, 4, 5, 6. Currently, I only have how many objects created on my picture? 2. So I have 2 objects created. All right. How many possible objects can I create? 6. Okay. But remember, my array of size 6 is large or small?
Pretty big.
Relatively speaking. Small, right? Because each of these things is taking up, 1, 2, 4 bytes, whereas these might be taking up 100 bytes. Well, I mean, obviously these are really small objects, but I think you're tracking with me. So I can allocate up to 6 objects, but I only have 2 objects allocated right now. So only 2 things have been created that are large, as opposed to creating all 6 things that are large and then eventually filling in their data. Right? So here I'm basically going to create objects on demand, right? If I need a new object, let me put it in the array where it needs to go. If I don't need it, then don't create it. Right? Don't take up that space if I don't need to take that. Does that make a little bit of sense? Okay, so which side do we want to work on? Probably this side. What is the type of this object? What are they? They're records, right? So their type is record. All right. So if I have a record and it's dynamic, to get to it, I need a pointer. Agreed? Which means the base type of this array is what?
Record star.
Okay. Everyone tracking? You need a record star pointer to point to a dynamic record. Right? We did that when we talked about dynamic objects. It just happens to be an array of pointers as opposed to a single pointer. Which means that this has to be a what?
Record 2 stars.
Okay. Which the only time that we ever saw 2 stars was when we created what? 2-dimensional arrays. Is this a 2-dimensional array though? No. It's a how many dimensional array? Only a 1-dimensional array. Right? It's a pointer that points to an array of pointers. And that array of pointers points to objects. Does that make sense? Ooh, you ready for the question? All right, you guys want to get 100? Without syntax error, which is a 0? Where do we start? I mean, it should be easy to know where we start.
Start with R, right?
Start with R. That's literally the only name of a variable we have. Right? And obviously in your program, you're going to have more than one name. But remember that you don't get to make up names, right? You only have the names available to you in the scope that you're at. So I only have what? R. So let's use our logical deduction and realize that I have to start with R because it's the only thing that I have. So I do R, right? Let's break it down. R is a pointer to a what?
An array.
An array. All right? Don't go any farther than that. R is a pointer to an array. How do I get to elements in an array? What do I use?
Brackets.
Brackets. Great. Regardless of whether the array was created dynamically or not.
Okay.
Okay? So what index needs to go in here?
1.
1. Everyone good with that?
Yes.
R bracket 1 is this pointer. Right? And so even if you wanted to, right, just look, right, ignore everything else and just look at what's in the red. Okay? Don't think about the fact that there's an array and there's other objects. We are at a pointer that points to a dynamic object. Agreed? Are we good with that? How do I access members in a dynamic object? What do I use?
Arrow operator.
Good. The arrow operator. Right? And which member do I want to access?
Num.
And what do I want to store in a num?
100. How would we write that the long way? Would R bracket 1 be in parentheses and then a star?
Yes.
Yeah.
Mm-hmm. Or you really want to write it the long way, you can say R, you can do star R, take that,
And then,
you reference it again,
oh my god.
and then do dot num.
I don't even know why I asked. That's,
Actually, sorry, this should be star R. We went down one, so it'd be star R plus 1. This is how you would do it if you didn't have nice syntax for it. Right? Kind of looks that way. Although it's not. R plus 1 says take a pointer, because R is a pointer, and add 1 memory address to it. And when you add integers of memory address, it doesn't add 1, it adds 1 memory address of whatever it is that you're doing. So it takes us down a full memory address, however big a record star pointer is. So 1 byte, 2 bytes, 4 bytes. The plus 1 is how many bytes, right, for each one are you going to do. So we do that, and then if we dereference it, it takes us to it, right? And then right?
We do reference
I have to
again.
use the dot operator, but I need to use the star to then move us down one more, down here, and then the dot.
Ah.
Don't do that. You don't understand what that's doing? That's fine. Right? But what are we doing? We're saying access, right, element 1, which is really the second element of this array, which is a pointer to an object. So I need to use the arrow operator on pointers to objects to get to this, right? And then I want to put 100 in. How do you feel about that? Which is okay, right? We can sort of good. Right, sort of good. I think I have an example of that.
This point is just keeping them separated from the other 3 examples.
Right? You know, like you did a bunch of other things too. I will say this though, this is what your assignment's going to be, where you're going to have a pointer to a dynamic array, and that dynamic array will point to dynamic objects. And you'll start, it'll be empty, but then when someone says like add to your, right, to your class object, then it will add, right, a dynamic object and allocate, right? And then the recall that I give you, because that's not complicated enough, right, is that what happens when this array gets full? Can I allocate more things? No. Can I just add more memory to arrays? No, you can't. And that's because arrays are stored in contiguous memory, right? They're next to each other. And there's no guarantee that the next memory is available. What do you think you have to do?
Just make sure it doesn't go over.
What? Well, okay. So I could just say, yeah, 6, that's all you get. Sorry, you screwed up, right? You didn't allocate enough. We're done, right?
To redo it? You have to reallocate it?
Reallocate it, right? Create a new one.
So, and then you have to save all the previous stuff in the array, right?
Yeah, right. So, right, think of,
So like if someone has a bunch of stuff stored and they say, I want to increase it by 1, you have to save all the stuff in it and then make it bigger.
But the good news is, what am I moving? Am I moving objects or am I moving arrows? Arrows. And what's easy to move? Objects or arrows? Arrows. So in fact, there is overhead, but the overhead's real small compared to having to reallocate, right, objects. Imagine if the array was not dynamic objects, it was just an array of objects. So I had 6 objects allocated. I'd have to create a bigger array, then I have to go to each object and copy the data from this to my bigger array that just allocated more objects before I have to get rid of this one. Yeah, right? So that's what I was working at here. So I created some temp, right? That's also a record star, and it points to a much bigger array. Let's go this way. Right? So it's bigger, and then I just have to say, okay, this first spot points to the same thing that this points to. The second spot points to the same thing that that points to. Right? Notice, did I have to move the objects? No, they're fine. Right? They're just hanging out in memory. I just have 2 different arrows to them, and then eventually this goes away.
Yeah.
Right? But that's okay because, right, I have new arrows to those things. Right? And then eventually temp's going to have to go away, so then this thing here will have to point to my new array. Because this was also pointing there. Okay. This is just a primer. I'm going to talk about that in detail next week. Because by the end of this week, when I introduce the assignment, I want you to get just the easy part. Next week, we're going to work on the hard part.
So we're getting to the red course now?
Yeah, we're getting kind of deep. Feet are more than wet now. This is not an assignment that you can do the night before. You could have done assignment 1 the night before because it was review, and so if you remembered what you did previous semesters, right, you could probably write it in one night. This one, if you do, great. You're really smart, good for you. But, like, I can write it pretty fast, but that's because I wrote it, right? So I know exactly what it's asking for. But for you to like read it, interpret what it is that I'm asking for, and then to be able to write it is going to take you time. And so you're going to have to devote some time in the next couple of weeks on this. This is your biggest assignment. It is the hardest assignment. The next assignments, if I give them to you right now, would be harder. But by the time we get to those, you'll be rock stars with pointers, and you'll be doing better.
How many assignments do we have back to the third one?
This was the biggest, is worth the most points. So 5 assignments in total. You did kind of a medium-sized one, and then you did a small one with new cat, and then you're doing this really big one, and then you have 2 like medium-sized ones. And the next 2 will be based off of examples in class, so that you should be able to kind of infer. This one, right? This is the example that I'm giving you with all these really bad arrows. So, right? Good luck. What was I going to show? Oh, so when you start writing the assignment, this dynamic objects and a dynamic array is probably a good place for you to look. You'll notice that I have a structure and I have a class. Okay? Which means I have 2 blueprints, right? 2 blueprints. One blueprint to create a structure and one blueprint to create a class. And what's going to happen is that my class is going to create an array of my structures, right? All internal, which means that the outside user doesn't have to worry about all of this nitty-gritty details. Don't worry about the tilde one. We're going to talk about that in a second, right? Here's my constructor. You notice that it takes a size because the constructor to create the dynamic array of size, right? So size has to come in. I want to create it, right? I have fill up, I have output. And then the crazy thing here is that we have scores, star, values underscore. 2 stars, because it's an array to an array of pointers which point to objects. Right? We're kind of 2 off from it, so we need 2 stars. Let's not worry about main. Let's talk about my constructor. Right? I'm going to keep track of how big my array is, so I'm going to say size underscore equals size. But then I'm going to say values underscore equals new score size star size. Meaning that at creation of my object, remember that's when constructors run, right? When the object is created. So at creation of the object, right, I'm going to create a new score array or star array of some given size. So when my object is created, right, I had a values underscore, which was of type score star, right? That was a member variable of my class, okay? And then I'm going to say that at creation, I'm also going to create a new score star array of some size, in this case 3. And I'm going to point here, which means I also have another variable called what? Size underscore, whose value is? Good. Once again, I have 2 private data points of my object. One is size and one is values. All right, let's talk about the fill up function. We've done fill up before, right? Fill up is basically like loop through the array and fill it up with values, okay? So that's what the fill up function is saying. I starts at 0, I less than my size. I increments every time. But line 66 is a little bit new. We say values bracket I equals new score. What is that doing? Values at location I, and I started at what? 0. So this place right here, which is a what?
Score star.
Score star. So it's a pointer, right? It's going to point to a what? A new score object.
Mm-hmm.
Right? And my score object has a score and a max. Right? So I've only allocated one object currently in my loop. Right? And I'm going to ask the user, right, give me that score number, right? Values bracket I, which is now an object. Right? Values bracket I is an object that I created, right? And I'm going to say what the score is, right? You got a 99, and the max was 100. Then it's going to loop. On the next loop, it's going to say values bracket I, which is the next location, is going to get assigned a what? A new score again. Right? Does that make sense? So I'm allocating, but it's not all allocated at once, right? I'm allocating one at a time. Right? You notice fill up, because it's called fill up, it's allocating all of them. You could just have like an add function, and it would just allocate one. And if I wanted a new score, I'd call add again and allocate the next one, and the next one, and the next one. So there's some dynamic memory that's been allocated, right? And all of these, size underscore, values underscore, they get created, right, inside of some object. And in my example, it's a dynamic object. Did not have to be dynamic, it just happens to be dynamic. Questions? Ignore delete. This is what I'm going to talk about in a second. Your lab today is not a dynamic array of dynamic objects, okay? You're going to create a dynamic string variable, because strings are really classes, which means that the variables that get created from strings are really what? Objects. So if you create a dynamic string, you can't use a dot operator on it, you have to use that arrow operator. Okay, so that's what your lab today is about. I'm just putting that caveat in because I'm going a little bit deep into this, but really, your lab's not going to be that deep. Well, let's get to the last stuff that we need to know about your lab, since we're already late and I'm only on slide 14 of 40. That's okay. Okay, so maybe I wanted to talk about heap and stack and all this cool stuff. So anything dynamic that gets created, and that means anything that you use what word on it? New. So anything that you say new comes from a special place of memory called the heap. Okay, and the heap, it's called that because it's just this heap of memory that when you call new, you like reach in and you say, oh yeah, I'll take that. Okay, yeah, I'll take that. No guarantee where that memory is, right? And, or if it's sequential or anything like that, just that, yes, there is memory for me to allocate. So every time I call new, it allocates memory, which consumes memory up in my computer, right? Meaning my program is now using memory that's been set aside that no other program in the computer can use until my program ends. Does that make sense? And that's how programs run on your computer, right? And we already made fun of Chrome because Chrome always eats up all your memory. So it's allocating right stuff all the time. Now, technically, you can fill up the heap, although, I mean, really, we're never going to do that unless you write a really bad program, because the heap's large because you have so much memory, right, in your computer. Right? In newer compilers, your program will crash. Older compilers, you'll get a null value back, null being the zero of pointers. Right? So null pointers are pointers that point to nowhere. No, they have no value. Okay? Does it make sense so far? Everyone good? These variables that get created from the heap, right, these dynamic variables, they don't follow scope rules. Okay, what are scope rules? What do I mean by that?
Only some variables exist within a certain scope.
Right, so variables only exist in a certain scope, right? Usually that's function scope. Get created at the beginning of the function, go away at the what? The end of the function. Okay? So if you allocate something with new, it does not follow scope rules, meaning if your function ends, that memory you allocated is still allocated.
That's memory.
And that's a memory leak. It's bad, right? That's a bad thing. This memory still exists in your program's still consuming it, but you can't get to it because anything that referenced it is gone. And that's because dynamic memory does not follow scope rules, but what does follow scope rules? Like, I don't know. Regular variables, right? Something?
Function?
Huh?
A function?
Well, functions help support scope, right? So let's look at this. So int star x equals new int. All right, which piece of this is dynamic?
The right side.
The new int, right? So that's the dynamic piece, right? X is of type int star. It points to that. But what is x?
The pointer.
It's a pointer to it, right? If I said int my int, right? Then I would just get a variable called my int of type int. It gets created. When does it go away? Not when the program ends, when the function ends, right? So this goes away when the function ends because it was a regular variable. Agreed? A pointer is a regular variable. Was it not created with just type, right? Identifier? Type, identifier, created the same way. So it follows all the same rules. It gets created when the function starts and it goes away when the function what? Ends. So when this function ends, what happens to x?
Goes away.
What happens to my dynamic thing? It stays, because I got to allocate from the heap. It does not follow scope rules, right? And we said that's a memory leak.
And what happens when the program terminates?
Okay, when the program terminates, just like any program, all the memory that program consumes goes back. So once your program ends, regardless of if you had a memory leak or not, all that memory is going to be deallocated and given back to the operating system. Well, the problem for us is not a problem because our programs run for like a total of a minute, maybe, right? But there are lots of programs that are supposed to run 24/7, 365.257, whatever. Right? So they're supposed to run all the time. And so if your program is slowly eating memory and it's supposed to run all the time, eventually it'll eat all the memory of the computer once you crash it.
Or games.
Or games.
Games. Like Minecraft, when you put in 100 different mods, and
Right.
70 of them are in there, and you run for 2 hours and crash.
Exactly. I mean, it's true, right? So yeah, the tiny little programs that we're running, are memory leaks really a problem? No. But once we build that scale out, then they become a big problem. So you should deallocate. I mean, because we're like, yeah, my program starts in main, it ends in main like a minute later. Great, everything gets deallocated, right? That's not the case in normal code. Yeah, right? On the fly, right? Just start putting more memory in and call it good, right? Don't write better code, just add more memory.
Yeah, come on, you know you don't.
That is one way to fix problems. It's just add more memory. It's all about, right? It's cost benefit. Does it worth my time to fix the problem, or can I just upgrade my server and call it good? And sometimes it's that, and sometimes it's the other.
Or it's both.
Upgrade the server
What?
like every hour.
And sometimes it's both.
Yeah, sometimes it's both. We're gonna do both, right? There is a thing about if you can improve something like 2%, or you can improve something 80%, right? You don't always go with the 80%, you go with whichever one's used the most. So if the 2% thing that you can improve is used 90% of the time, then you fix that as opposed to the 80% improvement that is only used 1%. So sometimes an incremental improvement in something, if it's the thing that's being used all the time, is actually better, right? And so trying to figure out where you put your time into. Or you let your boss tell you, depending on what. What else do I have? Oh, so this is just saying that we need to recycle. You didn't know this was that kind of class, did you? Right? We need to recycle our memory. Okay, if you're done using it, give it back to the heap. That way your program can use it again, or other programs on the computer can use it again as well, right? Don't be stingy with your memory. Use it, but when you're done with it, give it back. Okay? Does that make sense?
Do you have to share?
Yeah, you have to share. Anyone fail kindergarten because they didn't share? You're like, that's why they didn't let me? All right. So, yeah, the heap's large, but we still want to share. All right. And to share, basically to recycle, we just use the word delete. So everything I create with new, I need to get rid of, recycle with the word what? Delete. So we basically say that every call to new needs a corresponding call to delete. When you're done with it, right? You don't have to just delete it right now. Delete it when you're done with it. If I'm done using it, get rid of it. Okay, let's look at this example. Right, n star p, hey, I had that on the board, right? N star p, right? P equals new int. Everybody good with this? Right? Now, I want to be clear about this. When I say delete p, it does not say delete p. It says delete the dynamic variable that p is pointing to. Okay? When you call delete on a pointer, it does not delete the pointer. It deletes what the pointer is pointing to. It deletes the dynamic thing. So when I say delete p, right, what in my picture goes away? The red or the black? What about poor P? When does P go away?
And now it's confused.
Well, I could set it to null, but that's not going to make P go away. When's P going to go away? It is confused. We call this a dangling pointer because it's just dangling off into nowhere, right? It's technically still pointing at memory, right? Remember, because that's what pointers are. So it's pointed at memory, but it's pointing at memory that we just said is no longer, right, a variable in my program, right? So we want to fix that with making it to null. But what is going to happen to P? When does P go away? Okay, not just the program, but the function, right? Because P is a regular variable, it follows scope rules. So when the function ends, which sometimes when the program ends, because it's main, but when the function ends, then that thing, right, goes away. So the non-dynamic things go away when functions end, right, when scope says goodbye, right? The dynamic things go away when you call what? Delete. Does that make sense? So if I want to delete a dynamic thing, I use delete. If I want to delete a dynamic array, I use the word delete. If I want to get rid of a dynamic object, I use the word delete. Okay, but with arrays, there's a little bit more we have to do because since it's an array, we use square brackets. So if I create a dynamic array with square brackets, I delete with square brackets the dynamic array. Okay. Why? Well, let's talk about that. Here's A, right, points to a new integer array of size 5. That holds in, this is an int star, right? This is a regular variable, right? Its type is pointer, right? But it's a regular variable, meaning that it goes away when a function ends. Listen. If I just said delete A, what do you think is going to happen?
Just gonna delete the first element, right?
Right, it's going to delete the first element. Because when I said delete P, it deleted, right, one size of whatever P was, right? One int, right? And when I say delete A, it's going to say, oh, 8 is an integer pointer, so I want to delete how many integers? 1. And so what is it going to get rid of?
First element.
The first element, which if I drew a better arrow, right, that's where it was pointing to. So now my arrow points to what?
Nothing.
Nothing. What's left over?
The rest of the array.
The rest of the array, which is a what? Memory leak.
It's a bigger memory leak.
Yeah. When you have arrays, the memory leaks get larger because arrays are bigger, right? And to fix that, you don't even have to say how big. You just put square brackets on it.
It's
Right.
everything.
And it knows how big it is. All right? So put square brackets on your delete, and that doesn't just delete the first element of the array, it deletes what?
All of it.
All the elements of the array. Yeah, so my pointer is dangling still, right? And so after I do that, a lot of times what you'll see is A equals null, right? And all that does is it just brings the pointer kind of in, right? The value is null, right? The good part about that is now if you dereference a null pointer, your program will crash.
Oh.
Yeah, you heard me right. The good part about that is that when you dereference a null pointer, your program crashes. When you dereference a non-null pointer, but it points to who knows where, guess what happens to your program? Garbage, crashes sometimes, garbage other times, right? Do we want unpredictable results in our programs? No, we want what? Predictable. We want it to always crash and then fix the problem. Not, oh, it crashes sometimes and it doesn't crash other times. Oh, great. It's not predictable, so I can't figure out exactly what's happening. Yeah, well, because it's still pointing to memory, but that's memory that you've now said I don't want anymore. But just because you don't want it anymore, it's still the ones and zeros in memory until something else takes it. So depending on the timing of things, it might still just be those ones and zeros, so you can still access it. But we never want to access memory that we're not supposed to access because we get unpredictable results. Sometimes it's crashing and sometimes it's works, which is not what you want. You just want it to crash or not crash, not, yeah, sometimes when I feel like it, I crash, and sometimes I don't. Or even worse, what you don't want is what? It works fine on your implementation on your computer, and then you turn it into me, and what does it do to me? It crashes, right? That happens a lot because you guys are all compiling kind of on the same thing in CodeEnvy. I'm compiling in my own Linux distribution, and so sometimes where my memory is different from your memory, and so it works fine on yours and doesn't on mine. Remember, pointers are your what? Best friend and your worst enemy, right? Worst nightmare. I hope you don't get nightmares.
Oh, really good.
Dynamic multidimensional arrays are also dynamic, so I have to use delete as well. So you just do it backwards. So you can't just say delete the multidimensional array because the multidimensional array pointing to other arrays. So I created 8 arrays. How many arrays do I need to delete? 8. So I need to do the opposite, where I loop through all of the arrays and delete them. This looks so funny, right? Delete, square bracket, delete the array that A at I is pointing to. Right? And then once I deleted all those arrays, now I can delete the A array. Okay, we said that. We said that. It's dangling, pointing to null. Yay. Okay. Yeah, we said that. Yeah, we did that. I don't know why we have more examples. We don't need that. All I'm going to show you about delete is if you're like confused about syntax to create or destroy dynamic things, this delete is the thing to look at because in it, I give you the syntax to create a dynamic variable. I give you the syntax to create a dynamic array. I give you the syntax to make a 2-dimensional dynamic array. And then I give you the syntax to delete a dynamic variable, delete a dynamic array, and delete a dynamic multidimensional.
Where is that?
That's just on our so in your repository. So for you in your PA1 or PA2 directory, there's a class examples folder, and everything that I always do in class is in the class.
I just tried to pull that and I didn't get class like 13 or 14.
Did you get 13? Well,
Yeah.
then I better make sure that I have 13.
I got the labs 13, 14, 15.
But maybe not the class examples.
No.
I'll make sure they're up there. So this is a good one to look at for everything that we've been talking about. I've been talking a lot. I'm sorry. But I think you need destructors for your lab today, so I better talk about it.
Destructor.
We can do destructors in like 2 minutes. You guys ready? What do constructors do? They construct things. They make your objects. So what do destructors do?
Delete them.
They destroy your objects. Okay? You know what? You get a freebie default constructor, right? If you don't make any, you get the freebie one, right? The compiler writes it for you. You also get the freebie destructor. So there's a default destructor that gets written automatically for you, which does nothing. But that's fine, because until last class, did we know how to make dynamic things? No. So did I have to worry about what happens when my object gets deallocated? No. But now, we're going to start creating this kind of stuff, where I have some object, right? Some object, and here's its members, right? And maybe the B member is a pointer to an array. Does that make sense? Right? So my object allocated an array, and it allocated it with the value new. So every call to new needs a call to what? Delete, right? Well, we can't trust the user to know how to delete my array that I created behind the scenes where they don't get to see it, right? So if I called new to create an array, then I need to call what? Delete. But really, when do I need to call delete? When what? When I no longer need it, right? When I'm done with it? Well, really, in an object, I'm done with it when the object is going away, right? It gets deallocated, leaves scope if it's a regular object, or it's deleted if it's a dynamic object. Does that make sense? So I need like a, hey, it's going away, but I have cleanup to do. Please tell me that to do my cleanup. Okay? So if a constructor gets called when an object is created, a destructor gets called when an object is destroyed. And the 2 ways that we destroy objects are the same 2 ways we destroy any variable. When it leaves scope, or if it's dynamic, when someone calls delete on it. Does that make sense? Right? So when it leaves scope, or when you call delete on it, that's when the destructor gets called. And that's where you want to call things like delete to delete your dynamic array. Does that make sense? Okay, it gets called automatically, just like the constructor gets called automatically. And it's pretty easy, because a constructor is named after the class, right? Your class is called foo, your constructor is called what? Foo. Destructors are also named after the class, except you put a tilde in front of it. So, and you don't give it arguments. It doesn't have a return type, right? It's a special function. So let's get to a good slide. So if I have a class named dummy class, then the destructor is called what? Tilde dummy class. Okay. So in my class declaration, it would look like this. Notice it should be public, right? Because you need access to it, right? And the class definition, it's the whole duplicate, right? Class name, colon, colon, and then tilde class name again, which is the name of the destructor, right? You'll notice the comment here is what? Delete what? Dynamic variables. Guess what? If you don't have dynamic variables in your class, don't worry about a destructor, right? But if you have dynamic variables in your class, then you best do that. Make sense? Questions there? Right? Hey, look, I created an object. Everyone good with that? Right? It's a regular object, which means it goes away when the function ends. So in this function, when I say return 0, function ends, destructor gets called. Okay? Do I have to call it? No, it gets implicitly called for me, right? It gets implicitly called for me. Or if my object is dynamic, notice it's dynamic because I use the word what? New. How do I get rid of dynamic stuff? I say what? So when I say delete object, that calls the destructor for that object, which also might call delete, which is fine, right? Because it needs to clean up its stuff before I clean it up. Remember, when you write a class, you're hiding. Remember, encapsulation says I'm hiding the details of my class, right? So if you're going to hide the fact that you're creating dynamic stuff, then you also need to clean up the dynamic stuff without the user even worrying about it. Does that make sense? That's what happens like with strings. When you create strings, they're really dynamic arrays of characters, right? When strings go out of scope, right, they have a destructor that cleans up your dynamic array of characters. Right? All this stuff that's happening magically behind the scenes. Isn't it so great? Good? All right, I'm going to make sure that those are up on Canvas, or up on your repo, because apparently they're not. So if you will need to do a git pull to get those class examples, then great. And then remember the meeting that I said I had to go to last Wednesday? It's actually today, so I got to go. Who wants to be in charge while I'm gone? Anybody?
You mean Monday? Missile's got it.
Missile's in charge, okay? Don't give them all the answers. Okay? Today's lab,
Step up.
you are creating dynamic strings, okay? Remember, strings have number functions like, dot length, dot size, dot find, all that kind of stuff. The key here is that because it's a dynamic string, you're not doing dot length, you're doing what? Arrow length. That's really all it is. Otherwise, it's kind of the same lab as we did strings like a while ago. But we're not doing dot operator because they're dynamic. We're doing what? Arrow operator. Except you have one function, I think it's the last one, where you're doing like a replace, like find and replace. You'll notice that the first parameter is string star, it's a dynamic string, but then it has like old word and new word, and those strings aren't dynamic. So if they're not dynamic, we don't use the arrow operator, we use the what? Dot. So pay attention. If it's a pointer to an object, we use the arrow operator. If it's a dot, or if it's a regular variable, we use the dot operator. So just pay attention, right? You need to ask yourself, is what I'm working with dynamic or is it not? Right? And so is it the arrow operator or is it not? Does that make sense a little bit? Anybody have questions? I'll come around and then I gotta go. Let's see, CD. So I'm pointing towards the
Use my prime example of a pointer.
So he asked me, who is the leader? I'm just gonna give you the memory address. I don't know.
So you wanted what? Oh, you wanted 13? All right, look at that.
That is sound much.
Good news, the next two classes, we have no class examples. Actually, the next three, I think. It means that I'm not giving you new syntax. So I think that's good.
I can't tell if the fence still covered yet.
I'll let you do it. That gets all makes it matter though.
find
Oh,
character.
like that, right? That's what it's.
She had the.
All right.
Because I'm trying to get like these more characters for everything. I want to get excited for things.
Come on, get pushed. Alright, I'm gonna go, I'm gonna let people in now.
I'm just a player.
I feel good to be the kid.
No, I'm the player, so I'm playing with the Yeah. Who's in charge? I'll just give you the memory address. 0136
What happens? Something very bad happens when you point at another pointer that's pointing in the corner.
It seems like a loop.
Yeah, it's an endless loop.
So, what resource does it use up?
Yeah, memory, just because only memory, if you're gonna point, it's gonna point back, it's just gonna keep going back and forth. Yeah.
Runtime.
Yeah.
That's all you get.
That's what happens when you point a pointer to a pointer that points to a pointer. That's when you're pointing back to itself.
You can tell we've been productive. I think you taught us recycling the argument about abusing the return.
Probably that's because.
Yeah, no. But that thing is it's pointing to a variable it's doing.
Can't wait for this.
And that variable points back.
It's not right.
No, and either I have to put it back, the server will overload, you'll try to play it.
Yeah.
Multiplayer garbage, and it will completely broken.
So now,
Either my game is
running
corrupted, or it is.
another way to do it that is fourth one is after the mission starts.
There's gonna say, the guns are broken, but a week later, we have to nerf.
But I want to just have the code bases and maybe this forward.
But you got, it's really, you got a lot of stacks.
Yeah,
There's that.
yeah. We got it on one line, you
The
got
reason why is
it
because
power
it's
that's
free
production.
shots. And yeah, so.
Otherwise, when you work on replace.
Your charge now. He's been to me. You just get the business.
That's a smart pointer. If it's a bad sign, if you point
It's
to
fine.
means it's not.
So then, that,
Because eventually,
I think it's on my side, you almost
Please don't
plus
point
plus.
back all the way up.
Yeah.
The last one just has to realize that there's nothing else, there's no need to put anything else. And then it just goes, there's no need for Uber anymore.
So, ignore size T, just leave that as E.
I'm just helping.
Well, there's also nobody left to be
Yeah,
a Uber, so it's not like.
So you just try to figure out which one makes
Point
most
back
sense.
to the beginning, go back.
So what are the first one? Like you say, I'm gonna place starting at location 9. I'm gonna replace 5. So it's gonna work right. We were working with old word, new word, right? So you need to find where the old word starts, which is the location replace. And then, the old word dot length is the size, right? Just remember that replace on that one would be the arrow. Right, because yeah, you were trying to like create variables, but really you're trying to like have a string. So that's where you find it. So whatever this is, the string I dot find old word, that's where I is. And then old word dot length, word dot size, we don't want to see any new word. So I need to do that whole one. That's all. Because you need to find that location. Because I don't think you stored it. You just said that it's equal or not equal. Yeah, it means that when it says like throw null array reference, it probably means that one of those isn't right. Like here, you're saying int highest equals the array at 0, and then you're checking to make sure the array is okay. So you're accessing the array, and then you're checking to see if it's actually okay to access the array or not.
Oh, so I should put this before?
Yeah.
Did you push those things onto the?
I did. Yeah. If you do a git pull, you should get that. Yeah, see, that's what it says. This is fine. I'm still connected to the computer.
So I do that.
Oh, yeah, but you need to do that. You need to get into it first. So do cd space. Oh, right where you are. Yeah, that one. Yeah. Yeah, just do cd because you're already in project. So down here, just do cd space type p. That'll be good. Now, if you do up there, when you're using a password, you should be good. I'm going to disconnect so you guys can't see all the secret stuff.
Your whole meeting up on the
What's
screen.
going on? What is this guy do? I don't even know.
I mean, what your get stats is supposed to do, is counting how many letters. No, you're right, sorry, you're right. It's like only counting uppercase and lowercase is the easiest thing. But this digit does function the same way as very not about if this digit prints your array index 1, that'll be really close. Thank you.